These are your notes for Unit 6, Day 4 of Algebra 1. If you would like to see the warm-up, the review question, or any homework questions we covered in class today, just look at the finished notes. So today we're going to talk about how to divide a polynomial by a monomial. So a polynomial has many terms and a monomial has one term. We're going to learn how to divide those. Last class we learned how to multiply polynomials by polynomials, and today we're going to learn how to divide by a monomial. And we're also going to use long division to divide a polynomial by another polynomial. So dividing a polynomial by a monomial. So what we're going to do is remember the concept that if we wanted to add two fractions together, we would need a common denominator. So for instance, if we had 3 over 2 plus 5 over 6, and we wanted to add those together, the first thing that we would need to do would be to get a common denominator. So we'll multiply this guy by 3, that guy by 3, then we would get 9 over 6 plus 5 over 6. Now notice right now there are two separate fractions. 9 over 6 is its own fraction and 5 over 6 is its own fraction. And then what we can do is we can combine them into one fraction by adding the numerators. So we could have 9 plus 5 over 6. But if you really wanted to, you could take the 9 plus 5 over 6 or the 14 over 6 and break it back up into the two pieces that it was before. You could break that back up into 9 over 6 plus 5 over 6. So that's kind of what we're going to do for our first method on dividing polynomials by a monomial. Now notice on this first example, 8x to the third plus 6x all divided by 2x. What we're going to do, one of our options is we can divide this back into two separate fractions with both of them having a denominator of 2 over 6. So I can break this up into 8x to the third over 2x plus 6x over 2x. Since there's only one term in the denominator, I can do that. I can break it up into a monomial over a monomial plus another monomial over a monomial. And so now what you can do is you can reduce both of those fractions like you would normally reduce. So 8 over 2, both of those would reduce, and so you would get 4 over 1. And then x to the third over x, well, we did that earlier in this unit. You can subtract their exponents, and you would get x squared left on top. And then plus 6 over 2, those reduce to 3 over 1. And then x over x reduces to 1 over 1. So now we have 4x squared over 1 plus 3 over 1, which is just 4x squared plus 3, because both of their denominators are 1. And that would be my final answer, 4x squared plus 3. So again, we're separating them into separate fractions, and then we're reducing each of those fractions one at a time. So on the next one, we have negative 12y to the fourth plus 15y squared plus 3y, that whole numerator divided by 3y squared. So we're going to separate this one into three separate fractions. So we're going to have negative 12y to the fourth divided by 3y squared plus 15y squared divided by 3y squared plus 3y divided by 3y squared. And now we can reduce each of those fractions. So negative 12 over 3 reduces to negative 4. Y to the fourth over y squared reduces to y squared. And you would have a 1 left in the denominator. Plus 15y squared over 3y squared. Well, 15 and 3 reduce to 5. Y squared and y squared reduce to 1. So you would have a 5 left in the numerator and a 1 left in the denominator. And then plus 3y over 3y squared. Well, the 3's reduced to 1 over 1. And then the y over y squared, you would have 1y left in the denominator. So what we're left with now is we're left with negative 4y squared over 1, so just negative 4y squared, and then plus 5, and then plus 1 over y is left in the denominator. And we can leave it like that. And so it would be left with a trinomial. But notice it's actually not a trinomial because that last term is not a polynomial. Because you can't have negative exponents and you can't have variables in the denominator. So that would be my answer, but just know that that is actually not a trinomial. It does have three terms, but that last term is not a monomial because it has a variable left in the denominator. All right, so let's look at the next one. 16a to the 6th b to the 5th minus 8 8ab squared plus 6b, all divided by 2ab. So let's write this as 3 separate fractions. So 16a to the 6th, b to the 5th, all over 2ab, minus 8ab squared, all over 2ab, plus 6b over 2ab. And then reduce each of those fractions. So 16 over 2 reduces to 8. A to the 6th over a reduces to a to the 5th. B to the 5th over b reduces to b to the 4th. And you would have a 1 left in the denominator. Minus 8ab squared over 2ab. The 8 and the 2 reduced to 4. The a and the a reduced to 1. The b and the b squared reduced to b. So we have 4b over 1 left in that fraction. 6b over 2ab. The 6 and 2 reduced to 3. The b's reduced to 1. And then you still have the a left in the denominator. So my final answer will be 8a to the 5th, b to the 4th, minus 4b plus 3 over a. And that would be my final answer. All right, why don't you pause the video and try number 2. So break it up into 3 fractions and reduce. All right, so we have negative 2m over 6m to the 3rd n plus 18m squared n squared over 6m cubed n minus 9n over 6m cubed n. And now reduce. So the negative 2 and the 6 would reduce to negative 1 on top and 3 in the denominator. M over m to the 3rd, you would have an m squared left in the denominator, and you still have that n. And then 18 and 6 reduced to 3 and 1. M squared and m cubed, you'd have an m left in the denominator. N and n squared, you'd have an n left in the numerator. Negative 9 over 6, both are divisible by 3, so you'd be left with negative 3 and positive 2. And then the m cubed stays in the denominator, and then the n's both reduce to 1. And so we are left with negative 1 over 3m squared n plus 3n over m minus 3 over 2m to the 3rd. All right, so that's option 1 on all of these problems. You can divide them up into 3 fractions or 2 fractions and then simplify each fraction. Option 2 is something called factoring. So let's go back to that first example. When we want to factor and then reduce, what we do is we look at the numerator and say, what do those 2 terms have in common? So we'll start with the numbers. 8 and 6. What are 8 and 6 both divisible by? They're both divisible by 2. So I can factor out a 2 from both of those terms. So I'm going to pull the 2 out. It's like we're going to undistribute their common factor. And then we look at the x's. So what do the 2 x's have in common? We have an x to the 3rd and an x. Well, they both have at least one x in them. So I can pull out a 2x from both of those terms. And then we're going to undistribute. So I want to think 2x times what would give me the 8x to the 3rd? Well, I need a 4 and I need an x squared. So I have a 2x times, parentheses, 4x squared. And then I think 2x times what gives me 6x. Well, 2x times 3 would give me 6x. So notice if I distributed this back in 2x times 4x to the 2nd, I'd get 8x to the 3rd. And 2x times 3, I would get 6x. I end up with the exact same numerator. But now watch what happens. Then it's all over 2x. Remember last class I said that monomials can only cancel with other monomials and binomials can only cancel with binomials the exact same? Well, look at these 2 monomials. We have a 2x over a 2x. They reduce. They both reduce to 1. And so all you're left with is 4x squared plus 3. And then notice it's the exact same answer we got when we separated it into 2 separate fractions in that case. So that's factoring and reducing. So let's look at the next one. We have a negative 12, a positive 15, and a positive 3. What do all of those have in common? They have a 3, so I can factor out a 3, and then we look at the y's. We have a y to the 4th, a y squared, and a y. They all have at least one y, so I can factor out or undistribute a y from all of those. And now I have to think 3y times what is negative 12y to the 4th? Well, I need negative 4y to the 3rd. And then 3y times what is 15y squared? I need a 5y. And then 3y times what is 3y? Well, 3y times 1 is 3y. And that's going to be all over 3y squared. And so now, if you look, you have a monomial and a monomial, so you can reduce them with each other. 3 and 3 reduce, and then y and y squared reduce. And so we're just going to be left with the y in the denominator. So another way of writing this would be negative 4y cubed plus 5y plus 1, all divided by y. And that's another way to write that answer. And notice, if we divided each of those terms by y, you would end up with the purple box, negative 4y squared plus 5 plus 1 over y. All right, let's look at the next one. What do all of these have in common? So 16, negative 8, and 6, they all have a 2 in common, so we can factor out a 2. And then let's look at the a's. We have an a to the 6th, an a, and then no a, so I can't factor out an a from those because they don't all have an a. And then I have a b to the 5th, a b squared, and a b. They all have a b, so I can factor out a b. So I have a 2b that I can factor out. And then 2b times what is 16, a to the 6th, b to the 5th. That would be 8, a to the 6th, b to the 4th. And then 2b times what is negative 8ab squared. That would be negative 4ab. And then 2b times what is 6b? That would be plus 3. And then it's going to be all over 2ab. So now, if you look at the two monomials, because that's what can reduce with each other, we can 2 divided by 2 is 1, b divided by b is 1. So you're just left with the a in the denominator. So this can reduce to 8, a to the 6th, b to the 4th, minus 4ab plus 3, all over a. And then these two are equivalent. If you would write them all over a and reduce, you would get the exact same thing. All right, so those are two different ways if you're dividing by a monomial. You can write them as separate fractions and reduce, or you can factor or undistribute in the numerator and then reduce. All right, so long division. Let's review long division. So if I had 42,679 and I wanted to divide by 13, remember the first step is we're going to make the long division box, and we're going to put what's being divided inside the box. So 42,679. And then divided by 13. And then you remember, you take the number on the outside and you're like, okay, you just start with the first number. Can 13 go into 4? No. So then you expand it out. Can 13 go into 42? It can. How many times can 13 go into 42? Well, 3 times, because 13, and then you remember you multiply it. 13 times 3 is 39. And then in long division, you subtract going down. So 42 minus 39 is 3, and then bring down the next number. So we'll bring down that 6. How many times can 13 go into 36? Well, 2 times. And then you would multiply it. 13 times 2 is 26. And then we're going to subtract going down in long division. So I'd get 10, and then bring down the next term. How many times can 13 go into 107? Maybe 7 times? Let's see if that works. 13 times 7 would be 1, and then 2, so 91. Nope, it can go one more time. So we'll do 13 times 8. And 13 times 8 would be 24, and then carry the 2, so it would be 104. So we would get 3, and then bring down the next term. And then how many times can 13 go into 39? That'd be 3 times. So my final answer, 42,679 divided by 13, is going to equal 3,283. So that's just a review of long division. When we do polynomial long division, it's kind of similar to that. So let's look at this. X squared plus 5x plus 6 divided by x plus 3. So the first one is going to go in the box. So x squared plus 5x plus 6, and then the other one's going to go on the outside of the box. Now notice, it's kind of weird because they're not numbers, but we're going to do the same idea. So we're going to look at that first term on the outside, which is an x. And I'm going to say, what do I have to multiply it by to get the first term on the inside of the box? So x times what is x squared? Well, x times x is x squared, right? So that's what I need. I needed an x up there. And now we're going to multiply. So I'm going to bring that x and I'm going to multiply it to both of those terms. So x times x is x squared, and that'll go underneath. And then x times 3 is 3x, so that'll go underneath. And just like in normal long division, you subtract going down. X squared minus x squared will go away. It'll be 0. 5x minus 3x is 2x, and then bring down the 6. So now we're going to do the same thing. X times what would give me the 2x, right? So x times what would give me the 2x? Well, that would have to be 2. So x times 2, and then we're going to distribute again. So we're going to take that and multiply it. So 2 times x and 2 times 3. So 2 times x is 2x. 2 times 3 is 6. And then subtract going down. So 2x minus 2x is 0. 6 minus 6 is 0. And whatever you're left with is the remainder. Since my remainder was 0, it went in nicely. So x squared plus 5x plus 6 divided by x plus 3 is going to equal x plus 2. And that's polynomial long division. So let's look at another one. We have 2x squared minus x minus 6 divided by x minus 2. So let's put the 2x squared minus x minus 6 in the box, and then x minus 2 on the outside. And so x times what would give me the 2x squared? Well, x times 2x gives me the 2x squared. And then multiply this out. So 2x times x is 2x squared. 2x times negative 2 is negative 4x. And then subtract going down. 2x squared minus 2x squared is 0. Negative x minus negative 4x. So notice we're subtracting negative 4x, so that's like adding 4x. So negative x plus 4x is 3x, and then bring down the negative 6. And then we're going to do the same thing again. So x times what is 3x? Well, x times 3 is 3x, and then we're going to distribute that 3 in. So 3 times x and 3 times negative 2, so this would be 3x minus 6. Then subtract going down. 3x minus 3x is 0. Negative 6 minus negative 6 is also 0. So again, that's my remainder. So if I took 2x squared minus x minus 6 and I divided by x minus 2, I get 2x plus 3. All right, so now let's do some where we would get a remainder. So what do we do when we get a remainder? So 2x squared plus 7x minus 3 divided by 2x minus 1. So 6x squared plus 7x minus 3 divided by 2x minus 1. So 2x times what is 6x to the third? Well, that's going to be 3x, and then distribute that in. So this would be 6x squared minus 3x, and then subtract going down. 6x squared minus 6x squared is 0. 7x minus negative 3x is 10x, and then bring down the negative 3. And then 2x times what would give me the 10x down here? Well, that would be 5. So plus 5, and now we're going to distribute in that 5. So 5 times 2x is 10x, and 5 times negative 1 is negative 5. And then subtract going down. 10x minus 10x is 0. Negative 3 minus negative 5 is 2. So that's going to be the remainder. Now, when we did normal long division problems, sometimes you would do like 10, remainder 2, and I think that's what you guys would start with. Or you would keep going until you would get a decimal. Well, in polynomial division, we don't keep going. That's the good news. What you can also do is you can add, so we're going to add up here, and then you put the remainder over what you were dividing by. Well, we were dividing by 2x minus 1, so we're dividing by 2x minus 1. So we put the remainder over what you're dividing by. And that's going to be your final answer. So my final answer is going to be 3x plus 5 plus the remainder, which is 2, over what I was dividing by, 2x minus 1. All right, let's look at another one. 4x squared plus 8x minus 7 divided by 2x plus 1. So 4x squared plus 8x minus 7 divided by 2x plus 1. So why don't you guys pause the video and try this one. All right, 2x times what is 4x squared? That'd be 2x, and then distribute that in. So you would get 4x squared plus 2x, and then subtract going down. 4x squared minus 4x squared goes away. 8x minus 2x is 6x, and then bring down the negative 7. And then 2x times what is 6x? That would be plus 3. And then distribute in the positive 3. And you would get 6x plus 3. And then subtract going down. 6x minus 6x is 0. Negative 7 minus 3 is negative 10. So that's my remainder. And then you add the remainder over what you were dividing by. We were dividing by 2x plus 1. So my answer is going to be 2x plus 3 plus negative 10 over 2x plus 1. All right. Now, long division with polynomials, we need to be careful because we need every term. Meaning if it's missing a term, we need to add it. So in this first example, 9y to the third minus 3 plus 11y. Well, if I rewrote that in descending order, so 9y to the third plus 11y minus 3, and then divided by 3y plus 2 is okay. Are any terms missing? So meaning if you started with y to the third, are any of the y terms missing? Well, we have 9y to the third, then 11y. Yes, one of the terms is missing. We don't have a y squared term. So we're missing a y squared term. So we need to add it in. So we have 9y squared. We have 9y cubed plus 0y squared. So 0y squared means we have none of them, but we need to put it in so that our work lines up properly. So this is 9y to the third plus 0y squared plus 11y minus 3 divided by 3y plus 2. Now we can make our long division box and work out the problem. So we have 9y to the third plus 0y squared plus 11y minus 3 divided by 3y plus 2. If we didn't add in the 0y squared, when we go to do our long division, the like terms won't match up. But now they will because we added in the 0y squared. So 3y times what is 9y to the third? Well, that's going to be 3y squared, and then multiply that in. So you would get 9y cubed plus 6y squared. And now we subtract going down. So now notice since we have that 0y squared there, it lines up perfectly with the 6y squared. So we don't have to do any shifting of terms. So 9y to the third minus 9y to the third is 0. 0y squared minus 6y squared is negative 6y squared. And then bring down the 11y. And then we're going to do the exact same thing again. So 3y times what is negative 6y squared? Well, that's going to be negative 2y. And then we're going to distribute in the negative 2y. So we get negative 6y squared minus 4y. And then subtract going down. Negative 6y squared minus negative 6y squared is 0. 11y minus negative 4y. You would add and you would get 15y. And then bring down the negative 3. And then one more time. 3y times what is 15y? Well, we would need 5y. So plus 5y. Nope, just plus 5, sorry. And then we're going to distribute in that 5. And we would get 15y plus 10. Subtract going down. 15y minus 15y is 0. Negative 3 minus 10 is negative 7. So that's my remainder. And so remember, you always add the remainder over what you were dividing by. We were dividing by 3y plus 2. So my answer is going to be 3y squared minus 2y plus 5 plus negative 7 over 3y plus 2. All right, let's look at the next one. So we have negative 6a squared plus 5. Put it in descending order, divided by a minus 2. So it's missing a term. So negative 6a squared plus 0a plus 5 divided by a minus 2. All right, let's put it in the long division box. So negative 6a squared, there were no a terms, so we're going to put 0a and then plus 5 divided by a minus 2. So why don't you guys pause the video and try that one. All right, so a times what is negative 6a squared? That'd be negative 6a, and then distribute that in. So negative 6a squared plus 12a. Subtract going down. Negative 6a squared minus negative 6a squared is 0. 0 minus 12a is negative 12a, and then bring down the 5. And then a times what is negative 12a? Well, we need a negative 12, so minus 12, and then distribute that in. So we get negative 12a plus 24, and then subtract going down. Negative 12a minus negative 12a is 0. 5 minus 24 is negative 19, so that's my remainder. And then remember, we put the remainder over what we were dividing by, so a minus 2. So this answer is going to be negative 6a minus 12 plus negative 19 over a minus 2. All right, last one. 3x to the fourth minus x cubed plus 3x squared plus x plus 4. So there's no missing terms in this one, so no missing terms. And it's in descending order. And then in this one we have x squared plus 2, so this one does have a missing term. It's missing the x term. So this is going to be 3x to the fourth minus x to the third plus 3x squared plus x plus 4, and then divided by x squared plus 0x plus 2. So now we can do our long division. So 3x to the fourth minus x to the third plus 3x squared plus x plus 4, and then divided by x squared plus 0x plus 2. And now we just use that first term, so x squared times what is 3x to the fourth? Well, we need a 3x squared, and then distribute that in. So we get 3x to the fourth plus 0x cubed plus 6x squared. And then subtract going down. 3x to the fourth minus 3x to the fourth is 0. Negative x cubed minus 0x cubed is negative x cubed. 3x squared minus 6x squared is negative 3x squared. And then bring down the x term. And then x squared times what is negative x cubed? Well, we need a negative x. And then distribute that negative x in. And we get negative x cubed minus 0x squared minus 2x. And subtract going down. Negative x cubed minus negative x cubed is 0. Negative 3x squared plus 0x squared is negative 3x squared. X minus negative 2x is 3x. And then bring down the 4. And then x squared times what is negative 3x squared? Well, we'll need a negative 3. And then we're going to distribute in the negative 3. And we get negative 3x squared minus 0x minus 6. Subtract, so negative 3x squared minus negative 3x squared is 0. 3x minus or plus 0x is 3x. And 4 minus negative 6 is positive 10. Since we're all out of terms, that's my remainder. So we're going to put the remainder over what I was dividing by. So it'll be 3x plus 10 over x squared plus 2. Or you can do x squared plus 0x plus 2. So my final answer is 3x squared minus x minus 3 plus 3x plus 10 over x squared plus 2.